Today we're looking at lesson 2.5, solving literal equations for a variable. Our targets are to solve literal equations for a specific variable and use a formula that has been solved for a specified variable to determine an unknown quantity. Okay, let's look at our math terms real quick. Literal equation has more than one variable, and that equation can be solved for a specific one. So if you have more than one variable, they'll either tell you or you pick one of the variables to solve for, and you just treat the other variable like it was a number and work with it, move it around just like it was a number. Formulas are examples of literal equation. A formula is an equation written using symbols that describes the relationship between different quantities. A lot of formulas are in science, so it's a connection with that subject. A formula describes how two or more quantities are related. Formulas are important in many disciplines. Geometry, physics, economics, sports, and medicine are just a few examples of the field in which formulas are used. A formula is an example of a literal equation. A literal equation contains more than one variable. Literal equations and formulas can be solved for a specific variable using the same procedures as equations containing one variable. Solve the equation 4x plus b equals 12 for x. Okay, let's look at this example. We're just going to treat b like it was a number. We're not going to be able to combine it or anything, but we are going to be able to add, subtract, and move it around. Isolate the term that contains x by subtracting b from both sides. So you'll see here 4x plus b minus b, because just like anything, b minus b would be 0, and so it would go away on the left side. And we subtract 12 minus b because we need to keep our subtraction property of equality. We then can combine those like terms. Step 2, isolate x by dividing both sides by 4. So this is our division property of equality, where we divide both sides to keep it balanced. 4 divided by 4 is 1x. 12 minus b divided by 4. We can't really do anything with that. Okay, we can simplify it by taking 12 divided by 4 is 3 and leave b minus 4 like this. Or we could leave it the first way, 12 minus b divided by 4, because when you have 12 minus b divided by 4, you could put 12 minus b in like parentheses to keep it together, because it's one whole piece, one whole term. Or you can divide 4 into both of the pieces like this. Either way is fine. Let's look at A, solving each of these for x. So we want to get x by itself. Anything that's not x needs to be moved to the other side of the equal sign. Let's look at this one. So ax plus 7 equals 3. First step would be to move things that are the same together. We want to get rid of the 7 on the left by subtracting 7 from both sides with our subtraction property of equality. So ax would be alone now. 7 minus 7 is 0. It goes away. 3 minus 7 is negative 4. Still want to get that x by itself, so we're going to need to divide both sides by a. Remember, we're just treating it like it was a number. And so you can do things to it just like the same way you do numbers. A divided by a is 1. Leaves you x by itself, and negative 4 divided by a would be the final value that we can get on this one. B, cx minus 10 equals -5. So we do the same kind of processes. We're going to want to get the x by itself, so we're going to get rid of everything else. So let's do the first step of, let's do our addition property of equality and add 10 to both sides. Ten minus 10 is 0, so we're left with cx. -5 plus 10 is 5. Now we're going to want to get rid of the c being multiplied times the x. So we do the opposite and divide both sides by c with our division property of equality. We can't do anything further, so that's the answer. X equals 5 over c. And let's look at c, -3x plus 9, sorry, -3x plus d equals -9. Step 1, we want to get the x's by itself first, so we're going to have to get rid of the d, and subtraction property of equality, we're going to subtract d from both sides to get it alone, to get the x alone. Like that. That'll leave us -3x equals -9 minus d. Now we can divide both sides by -3 to get the x by itself. I want to divide this whole thing by -3. Or, well, I'll save the or for just a second. Hold on. -3 divided by -3 is 1, so that's x. Now, we can leave it like this, -9 minus d divided by -3. That seems to be an awful lot of negative signs. So let's do the other way and divide both of the things that we had together, -9 minus d. We'll divide each one separately by -3. So we have -9 divided by -3 minus d divided by -3. This is where a lot of people get confused with all these negative signs. -9 divided by -3 is +3. Minus d divided by -3. Well, if it's a minus, or remember, it's like adding a negative. So two negatives make a positive. It'll be plus d over 3. A negative divided by a negative, or because remember, another way to write this is if we had -9 divided by -3 plus -d divided by -3. Remember, subtracting is the same thing as adding the inverse or the opposite. That's probably the one part that'll confuse a lot of people. If you haven't practiced your adding and subtracting and dividing and multiplying by negative numbers for a while, we might have to have additional practice on that if you need it. All right, checking our understanding to make sure we got this. Is the equation 2x plus 4 equals 5x minus 6 a literal equation? And explain. Remember our definition, literal equations have to have two variables or more than one. Okay, it could be 3 or 4, so but we're not worried about that. Literal equation just contains more than one. So does this one have more than one variable? And the answer is no. It does not have more than one variable. It's not let me type. Hold on. No, it is not a literal equation because it doesn't contain more than one variable. All I see is x's. That's the only variable I see. So no. Number 2, describe the similarities and differences between solving an equation containing one variable and solving a literal equation for a variable. Well, the similarities, they are similar because the same properties of mathematics can be used. They still apply. They're different because still not going to know the other variable. You're just treating it like you do know it, but you don't actually know. It's different because you still are dealing with unknowns. You're not going to have like a straightforward answer. Let's look at example B. But before we do, let's just look over to connect to physics. Physics is a science subject that you can take in high school and college, and it's what my degree is in from college. An object's velocity is its speed in a particular direction. Its acceleration is the rate of change in velocity. If an object has a positive acceleration, it's speeding up. If it's a negative acceleration, it's slowing down. So the equation V, its velocity, is equal to V0, which is basically its beginning velocity, where it started at AT, at acceleration times time, t, time. This gives the velocity in meters per second of an object after t seconds, where v sub o is the object's initial velocity in meters per second, and a is its acceleration in meters per second squared. Let's solve the equation for a. V equals v sub o plus a times t. We want to make a be the only thing on this side by itself. Remember, making it on the thing on the right is the same thing as moving it around and making it the only thing on the left. But it's already on the right side, so we can leave it. So let's use our properties, and we're going to subtract v sub o from both sides. And it will be v minus v sub o. Okay, there are two different things. Equals a times t, because v sub o minus v sub o is 0. Now we want to get the a by itself still, so we need to divide both sides by t. And we're going to get that a, the acceleration, is equal to v minus v sub o divided by t. Okay, 4 different variables on this problem. It's a literal equation because it has more than one variable. V minus V sub O divided by T is equal to your acceleration. Determine the acceleration for an object whose velocity after 15 seconds is 25 meters per second and whose initial velocity is 15 meters per second. Well, we're just going to plug our numbers in. So determine the acceleration after 15 seconds. That's the time. That's how long it took. So we know we're going to be dividing by 15. The velocity is 25 meters per second. V, velocity, 25. And initial velocity, where it started from, the original velocity was 15. So 25 minus 15 divided by 15 will give us the acceleration. 25 minus 15 is 10, and 10/15 can be reduced. We can divide both of them by 5 to get 2/3. And remember, meters per second squared is acceleration. So meters per second, you write it like a division sign, meters per second squared. That's what A is going to equal. Acceleration. So part B, just plug in the numbers and work it out, and you'll get meters per second squared. Something you might want to look into is called unit analysis, and that will teach you how all the meters per second and seconds and meters per second become meters per second squared. And I said meters per second twice because there's a meters per second for the velocity over here and a meters per second for the velocity here, and just plain seconds down here. Meters per second minus meters per second is just meters per second, and divided by another seconds, and that's how we squared this, because we divided it twice by seconds. You already had it meters per second. You divided by this. That might be a little more complicated than we're trying on these problems. So right now, just believe me when I say it's meters per second squared. You can find out how you got an acceleration. All right, let's look at A. They're just showing you what we've already proved up here. And B, it seems to be the same thing. They just repeated the question. All right. On number 3, let's look at this first. Before we do 3, let's try this for B. The equation T equals 13P plus 108 can be used to estimate the cooking time in minutes for a stuffed turkey that weighs P pounds. Solve the equation for P, and then find the weight of a turkey that requires 285 minutes to cook. Okay? We want to make P by itself instead of the T. So T equals 13P plus 108. We want to get P by itself, so let's take away the 108 first from both sides for our subtraction equality purposes. So T minus 108 will equal 13P. And then we want to divide both sides by 13 to get the P by itself there. So t minus 108 divided by 13 will equal the pounds, P, of the turkey. Now it tells us that the time is 285, so we're going to say 285 minus 108. That whole thing divided by 13 will give us the weight of the turkey that we need. 285 minus 108. Well, let's see what that is. 285 minus 108 is 177 divided by 13. And we can round that, not round, we can change that to be 13 and 8/13 pounds, lb. S for pounds will equal to P. You need a 13 8/13 of a pound turkey. That's how long it needs to cook, is 285 minutes. Let's look at number 3. Solving for the indicated variables in each formula. We have our distance formula, pressure, kinetic energy, gravitational energy, and Boyle's law. We're going to solve for these variables that they tell us over here. So they're going to give us the formula, and we're just going to move things around using our properties until these are the variables we're solving for. So distance, d equals r times t. Distance equals rate times time. And we want to solve for r. So we want to get rid of the multiplying by times on this right side, so we'll divide both sides by time. And so this will be d over t equals r. The next one, pressure, where pressure on a surface is equal to the force applied divided by the area of the surface. This is why if you spread the force over more area, it's less pressure that you'll feel. And we're solving for force, so we need to get rid of dividing by A to get the F by itself. So we'll do the opposite and multiply both sides by A. And so our answer is going to be A times P, or AP, is equal to F. The force applied is equal to the area of the surface times the pressure on the surface. Kinetic energy is equal to 1/2 the mass of an object times its velocity squared. Remember, there are two kinds for this. We have kinetic energy and potential energy. When potential is the energy of an object at rest, kinetic energy is the energy of an object in motion. So we want to solve for the mass, basically. So we're going to divide by v squared and multiply times 2 to get rid of this one. So it will be k times 2, or 2k, divided by v squared. Two k divided by v squared will equal the mass, gravitational energy, U, gravitational energy, which is U, equals the mass times the acceleration due to gravity, 9.8 meters per second squared, if you ever need to remember that one in the future, at least on Earth, and times the height. So we're looking for the height, so we just need to divide out the mass and gravity. And that will just leave us with the height, but we need to do it to both sides. I know this is hard to see because it's hard to write with all this. We're doing the best we can. It's going to be U divided by the mass and gravity, and that will equal the height. In Boyle's law, the first pressure that you use times the first volume of the gas is equal to the second pressure times the second volume, or the final, if there's only two. When the temperature is kept constant, okay, because temperature changes to other things, to gases, and we're looking to just V2. So all I have to do is get rid of P2 multiplied times V2, which is the opposite, will divide. So P1 V1 divided by P2 will give us our final volume. Okay, so you could solve for any of the variables, and it's all up to what the question is asking for, using the properties of math. So math and science start going together pretty tight in the future if you continue your learning at physics class or even some chemistry classes and biology. All right, let's look at number 4. Solve the equation W plus I equals S over C for C. All right, I'll try this one on this, where I can type it better than write it. W plus I equals S divided by C. Now we want C to be by itself, but right now it's being divided. Okay, we need to kind of flip it over. And so to do this, we're going to multiply both sides by C. Because when we multiply division of C, C times C, it'll equal 1, and the S will be left by itself. I know we want C, but we're working to get there. So C times W plus I will equal S, because this dividing by C and multiplying by C cancels each other out, because it just ends up being 1, and that'll just leave 1S. Now, I want C by itself, so I need to get rid of this part. So we're going to divide both sides by what's being multiplied times C, W plus I. Okay, this w plus I divided by w plus I, that'll become 1 and go away, leaving us with just C, and we're left with S divided by w plus I. It does look confusing, but just remember, whatever your variable you're not worried about, you just treat it like it's a number. And you can do to it all things that you can do to numbers. Why do you think being able to solve a literal equation for a variable would be useful in certain situations? Well, we've talked about it just a little bit, but science formulas contain many variables sometimes, and need to be solved for specific unknowns. Sometimes you'll have certain informations. Sometimes you'll know an object's velocity, but you won't know the time, and you might know the acceleration. So sometimes you'll know the time and the acceleration, but you might not know the velocity. Sometimes you'll know the pressure or the gravitational energy. If you know, it depends on which one of these that you do know, that you can solve the rest of them for the ones that you don't know. It sounds confusing. I could have probably said that better, but go ahead and try 6 through 10. Remember, you're just moving things around, basically. Okay? If you're solving for D, you just want D by itself. Get rid of what's around it by using the properties that we've been using for the past couple of lessons. If you're solving for W, get rid of this by doing the opposite to both sides, because we have to keep both sides balanced. Go ahead and try 6 through 10.